Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working through the advent of code problems from 2021 and this is day 8. All right, here's today's problem. So we've got a 7-segment display and it's been damaged. So this is how a 7-segment display should work. When we turn on 2, segments A, C, D, E, and G would be on. But the wiring's been randomly rearranged. Okay. And then we're given an input that is the 10 unique signal patterns and then a 4-digit output value. Okay, so we get 10 patterns and a pipe, 4 digits, and this is what we're eventually going to have to figure out is these digits, I think. Okay, so we should be able to work out which combination corresponds to each of the digits and then decode the output value. But for part 1, we're focusing on the easy digits, which are 1, 4, 7, and 8. They each use a unique number of segments. So yeah, 2 segments is 7. Yeah, okay. So right now we're only going to count the digits in the output values. How many are there that are 1, 4, 7, or 8? Okay, so 1, 4, 7, and 8. I'm sorry, 7 uses 2, doesn't it? So 1 uses 2, 7 uses 3, 4 uses 4, 8 uses 8, or 7, all 7. So 2, 3, 4, and 7. Okay, so this part's not too bad, but the second half looks like it's going to be kind of tricky. So we'll read our line in. We can split our array, I guess. Maybe we should split where the pipe is. Let's do that. Is that right? And pipe is probably part of a regex, so I think I need to escape it there. I need to escape the backslash to put it in the string. So we've got pieces, and then we're going to split our, right now we only care about the second half, right? So we'll say digits is pieces sub 1 dot split, there's a space, and then let's just print this out and make sure it looks reasonable. And actually, we need to do this for every line, I guess. Input's going to have more than one line. What's the problem here? Hey, Daisy's getting violent down here. Oh, yeah, right. Okay. All right, it looks like that basically worked. We're getting an empty string at the beginning of the digits, which is okay. We probably just need to trim these pieces. So I'm going to trim here. And now the right side should look more reasonable. Okay, so digits is showing us 4 strings, which is what we want. And now we can go through and count the ones that are interesting. And then we're going to say how many there are, just how many appear. Okay. So we need to count. My while's in the wrong place, which is confusing me. Here we'll say if, we're going to say for each digit. seven, or right? Then count plus. And then here we need to print out count. I'm not 100% sure about this precedence, so let's just add parentheses here. 310. Okay, now for the tough part. Through deduction, we should be able to figure out the remaining digits. Okay, so we need to follow this process. So the process is do some careful analysis, and then you'll realize that only this arrangement makes sense. Okay. How are we going to do this? Okay, I think what we want to do, when we look at an input, we're going to know how many segments are turned on. And then we can look at that number and we'll have some number of segments it might be, right? So if we have a non-unique one, like say 6 segments are turned on, or 5, how about 5? 5 could be a 2, or a 3, or a 5. So when we see 5 segments, we'll know those 5 segments are A, C, D, E, G, A, C, D, F, G, or A, B, D, F, G. And so in the segments that are on, we'll be able to eliminate any options that are not in that list. I think this might work. All right, let's try to encode something like that. So I'm going to grab this. And then we'll create a structure that maps these. So I guess we'll have an array. It's an array of string. And so 0 is A, B, C, B, C, E, F, G, and is C, F. I think I'm going to try just eliminating the ones that can't work and see how we do. This might not be enough to do it, but I'm going to try that way. So let's see. I'm going to say unique digits. Pieces sub 0. Trim. Split. Space. And then we're going to go try to figure out the encoding. So we'll say we're going to have an array of wired segments. This is going to be a little weird, isn't it? I'm going to maybe need better variable names. And then we'll populate this with the string. So as we start out, maybe we'll call this lighted segments, output segments, output segments. We'll call this digit segments. So we're going to have our output segments. There are 7 of them, and each one could be wired to any of these. And then as we go through, we'll eliminate the ones that it can't be. So let's try that. So we'll say for string unique digit and unique digits. Now we're going to go through digit segments and look for the ones that are the right length. And then we'll look at output segments and eliminate any that can't be on in any of those sets. Okay, so we could really combine these. We could really do this by length, I guess. Let's do this. String digit segments by num_lit. Okay, so we'll have 0, 1, 2 is only CNF. 3 is only ACF. I think this is going to be helpful, maybe. Length 4 is BCDF. Length 5, we have ACDEG, ACDFG, and ABDFG. Okay, so all segments are there for 5. Length 6, ABCEFG and ABDEFG. I got the 9 wrong. ABCD, that doesn't have an E in it. So 5, 6, and 7 are all going to have all of the segments turned on. So if we do it this way, nobody's turned on with 0 segments or 1 segment. When we see the length of the number that are turned on, we can narrow down the segments they could be if it's one of these 3. I guess it's really only for these 3. And then I think we can also narrow down this will be digit segments on by num_lit, and this will be off. So if this is CNF, then ABDEG are off here. Here BDEG. Here we have AEG. And then for the 5, 6, and 7, none of them are off for 7. On the 5s, what can be off? So here we have B and F, BE and F, BCE and F. So B, C, E, and F can be off when there are 5 segments on, B, C, E, and F. And then when there are 6 segments on, D can be off, C can be off, and E can be off. So C, D, and E. All right. Okay, so I think this is going to be more useful now. So if we see how many are lit, we can see if they're 2 lit, then the ones that are on can only be C or F. The ones that are off can only be these. And so on. So when 5 are on, the ones that are lit could be anything. But the ones that are off can only be B, C, E, or F. Okay, so we're going to get a unique digit string. Then we're going to say, get the segments on. So we'll say segments on sub length of the unique digit. And then we're going to go through the characters in our unique digit. So this is, we'll call this seg. And then I need to track our possible, so it's output segments, right? So from output segments, so segment index, right? So we'll say seg index is seg minus A. So that'll give us the index into output segments. Then we're going to go through the characters in output segments, and we need to remove any character that is not in segments on. So say string new output is this. We'll go through our output segments subseg index, and we'll only add the ones that match the segments that are supposed to be on. Right? So char output seg and output segments subseg index. And then if it's not in segments on, if not segments on, or if segments on dot index of that character is greater than or equal to 0, then we'll add it to our new output. Oh, I think we can do this with, yeah, two char array, okay. And then after we've done this and got our new output, we have to put it back into output. So that goes into output segments subseg index. Okay, the naming is really tricky here. For each unique digit, we're going to do this. Okay, I think I need to keep doing this. How do we know when we're done? I guess we'll have a none found maybe. And then here we'll say while none, or we could even say while true. When none found becomes 7, we'll break out of our loop, I guess. What's the matter with this all of a sudden? Oh, yeah, okay. Okay, so we update our digits. Now we're going to look for any of these output segments that are of length 1, because that means we found the answer for one of the segments. So we'll go through the output segments. If the segment length is not equal to 1, skip it. If it is equal to 1, we're going to increment num found. If num found is 7, then we're finished. So we'll break the outer loop. Otherwise, we need to go through and eliminate this letter from every other output segment. So we're going to say, actually, do we need to, yeah, maybe we'll delete it from all of them and store it somewhere as an answer. I think we'll do that. Okay, we'll do this. Yeah, final output segments. And here, found plus plus, final output segment sub I equals output segment. And if we're done, we're done. Okay, otherwise we need to delete it from every one. So is index of the one that we found. index 0, then we're going to say output segments sub I, nope, j, equals this segment substring zero index plus this segment substring index plus 1. That should take it out. Okay, so for each one, get the segment. If its length is 1, count it as found, store it in our answer. If num found is 7, we're done. Otherwise, we go through and delete this from every row. Okay. That seems good. The other thing we didn't do is use the segments that are off to update our candidates. So here we went through the ones that were on. We also need to go through the ones that are off. All right. This is going to be very similar to this. But our loop here is going to be from A to G. And we need to skip the ones that are on. So if the unique digit contains it, that doesn't work, right? Index of greater than or equal to 0, then this is one we don't care about. Seg index is that. New output, go through the possible segments there. And if it's in output seg, okay, so this, yeah, this basically needs to be segments off. If it's in segments off, then we can use it. Otherwise, we can't use it. And then we store our output segment that's been updated. I think this might get us most of the way there. Here we definitely need to print out our final output segments. We're going to need to use the input from this example. So let's just have our single line here. And let's put AB first, because that's an easy one to watch. So if we should probably break here and see what happens. Okay, so theoretically we updated output segments. Ooh, that really worked. Okay, cool. So we saw A and B, so we know that A and B can only be C and F. And that part got updated correctly. Now the segment's off. I'm not sure if that's really going to do anything. But we'll let it run and see if anything happens. Okay, it did. So it eliminated the C and F. Right, that makes sense. So none of these can be C and F because those have to be C and F. And now we went through the next one, which was not useful, right? It's the 7. So 7 are turned on. That tells us nothing. We never learn anything from that case. Now we get one that's 5. Nothing changes. But it's more interesting which ones can be off on the 5 case. Okay, so 6 got reduced to B and E. So 6 is G. G has to be B or E. Is that reasonable? G is E, so I guess that's okay. I should be putting a breakpoint here too, in case we find something. All right, so we'll continue to go through here. Some of these are getting narrowed down. Interesting, 3 can only be A. So what's this? A, B, C, D is A. All right. This is actually getting narrowed down much more than I expected on the first pass. We're already done. A, B, C, D, E, and these have to be F and G. So let's see if that part works out correctly. F gets eliminated, this gets eliminated. Now we're on G again. So G is the only one we didn't figure out on the first pass. And then it got figured out, and then we printed it out. C, F, G, A, B, D, E. C, F, G, A, B, D. I think it worked. Okay, so final output segments appears to be correct. Okay, now we need to go through the digits and figure out what they are. So we're already splitting them up. Don't need this anymore. For each digit, not doing this anymore. In fact, we can get rid of count. Digit segments is what we want, right? These are telling us the segments that are on for each digit, except that I messed these up. So let's fix these. A, B, C, E, F, G. Did I just delete one that I shouldn't have? Is that what happened? A, C, D, E, G, A, C, D, F, G, B, C, D, F. Maybe I just deleted one. A, B, D, F, G. F, G. C, F. A, C, D. E, F, G. Okay, so 5, 6, 7, 8, 9. Okay. I think those are right. All right, so now for each digit, we'll go through each character in the digit. And then we need to translate this into the real character. So we're going to say we want to say segments equals final output segments C minus A, I think. Now we've built segments. So if we're going to match this up against our array up here, I think we need to sort the characters. So let's do that. Probably have to convert this to a character array. So and then we can do arrays.sort. and convert it back. And now that should exist in our list here, digit segments. So let's look for it. I guess we really want the index here, don't we? What are we inside of? This is 10. Continue with the next digit. And if we get to the end of this loop, okay. Might do the trick. Let's see what happens. Five, 3, 5, 3. That is what it was. Cool. Okay, so we need a new line at the end here. So that's after this loop. And that'll fix our output, and then we can change our input to the real input. And make sure this is all getting reset. So the only things outside our loop are these constant arrays, which seems fine. Okay, so this should print out a bunch of, okay, we got a bunch of 4-digit numbers. That's good. Let's make this throw an exception just so that we know if it's happening anywhere. It didn't. So then what's our input for the answer supposed to be? Add them all together. All right. So back here, we just need a total. And I guess this, yeah, we shouldn't be building this as a string, huh? All right, so we'll change this a little bit. Answer, this should be I. And then down here, we say total plus equals. Something like this, right? Let's just make sure that the answer looks reasonable. Okay. That's the right spot. And then at the end, or not answer total. There we go. All right. Now this one was pretty tricky. So I'm pretty happy with the approach, I think. One of the really key insights here was this off list. Using the segments that were on would get us partway there. Daisy points out we could have used some kind of constraint satisfaction approach, kind of like Sudoku, where, especially here, we realize that there are two segments that could be C or F, and that means we can eliminate those from all the others. So there's some stuff we could have done if we made our logic more complicated, but this was good enough since we only had 7 segments to worry about. As long as we take into account the segments that are off, we basically have this solved in one pass. So that worked out pretty well. This code's not particularly interesting. This part, I feel like I could combine these two loops if I stared at it for a while. I guess it's not as simple as just using the on or off string because the loop. No, that might be. Yeah, we probably could have combined these two loops. So I think I could have a loop that went over all the digits, and then if it's in unique digit, we use the segments on, and if it's not, we use off. That's probably, I could combine these two loops, I think. And then this part seems okay. I mean, this is really just saying if we solved one of the digits, then go remove that as a possibility from all the others. So that's not so bad. And then the digit part, we're looping through looking for things. We could have used a map. That would be a little more efficient, but whatever. For problems like this, I don't care about efficiency unless I run into the time limit or, I try to run it and I find out it's going to run for 5 minutes. So this isn't too bad. The hard part for this one was just the general approach. I'm pretty happy with this approach. For a small problem like this, it worked well, but there's a much more general approach we could have taken with a lot more code, or at least a lot more thinking. Well, that problem was quite a bit harder than the ones before it. Daisy pointed out that I needed to worry about segments that were off, and from there, we got through it. We'll see what day 9 has in store. Don't forget to like and subscribe.